Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 4, Lesson 2, More Work with Fractions of Wholes. So this is just a follow-up lesson to our last one. And in our last lesson we looked at something that's very basic, which is if I'm told that a part of a whole represents a certain fraction of it, so 3/5 of something is something else, then how do I find how big the part is? And of course, this is just as simple as multiplying the whole quantity by that fraction. Whenever I multiply a whole by a fraction, there's always a division by the denominator and a multiplication by the numerator. It's pretty much that simple. But this is such an amazingly important concept as a background idea to percent, which is what this unit really is all about. Before we get into percent, we want to make sure you have all these basic concepts down. So let's do a little bit more work with finding the fraction of a whole in this particular lesson. Let's do it. Let's start off in exercise number 1. Here we go. The pattern below shows a certain number of cubes in dodecahedrons. Yep, that's actually what they're called. We simply want to think about how many cubes there are compared to all the solids, so all the shapes that are sitting there. Letter A simply asks us to fill in the number of cubes, the number of total solids, and then give the ratio of the cubes to total solids expressed in multiple ways. So pause the video now, set this, fill in the blanks, that should be easy, and then come up with those ratios. All right, real important. Sometimes when we look at ratios, we're looking at sort of like a part to another part, right? But the ratios that we're going to be mostly concerned with in this unit are parts to the whole. There are 6 cubes, right? 6 cubes, and there are a total of 9 shapes. So you have to be careful, right? We're not looking at the ratio of the cubes to the dodecahedrons. That would be 6 to 3. We're looking at the ratio of the cubes to all the shapes, right? Now, what is that ratio? Well, that ratio is 6 to 9, which, when reduced, divide both numerator and denominator by 3, is 2 to 3, right? And we could also express that as either 2 with a colon 3 or 2 to 3. Okay, all of those are completely appropriate ways. The fraction 2/3, the 2 colon 3, you can't barely see that colon, and then 2 to 3. Now, it's one thing to set up the ratio, it's another thing to make sure you understand it. That's what letter B is all about. Let's take a look at it. Fill in for the simplest ratio. For every blank solids, there are blank cubes. Also, fill in for the simplest fraction. The fraction of all solids that are cubes is what? All right. So this should be pretty easy, especially after the last lesson. Why don't you pause the video and fill in all those blanks. Now again, you got to watch out. You got to make sure you read carefully. It'd be very tempting to say for every 2 solids there are 3 cubes, but that's not true, right? The whole point is the ratio is 2 cubes to 3 solids, or read the other direction, 3 solids to 2 cubes. So for every 3 solids, there are 2 cubes, right? Fill in for the simplest fraction. The fraction of all solids that are cubes is 2/3, right? 2/3 of all the solids are cubes. Now, let's take a look at letter C. If there were 42 solids with the same ratio of cubes to total solids, find the number of cubes in 2 different ways. Letter I, or the first way we're going to do it, is by using a proportion in algebra, and 2, or 2 I's, using a product based on the fraction of solids that are cubes. All right, so one way to figure out if we had 42 solids, how many cubes we had, would simply be to do the following. We could say, well, there are 2 cubes per 3 solids, right? Set up a proportion, right? Now maybe we let C be the number of cubes, and there are 42 solids. So now I could simply cross multiply. All right, we'd get 3 times C is equal to 2 times 42. that would give me 3 times c is equal to 84. Now I'm going to divide by 3 on both sides. All right, now I might have to go over on the side of my paper and do 84 divided by 3 if I don't have if I don't have my calculator with me. All right, and we find that c is equal to 28. So if there are 42 solids, right, then there are 28 cubes. But we really should be able to do this problem in a much simpler way than all of this, right? We know that 2/3 of all solids are cubes. So since 2/3 of all solids are cubes, and we know that there are 42 solids, the simpler way to do this is just to do 2/3 times 42. Keep in mind, right, we're going to do a division. 42 divided by 3 is 14. We can now do 2 times 14, and that gives me 28. All right, so certainly if you know the fraction of the whole that the part represents, then just multiply the whole, 42, by that fraction, 2/3, and you'll get the number that fall into the part being the number of cubes. All right, let's keep working on this idea. Here we go, exercise number 2. In a gymnasium full of kids, 7 out of every 20 kids are wearing hats. There are 100 kids total in the gym. Letter A asks us to find the number of kids wearing hats, H, by using a product. Letter B asks us to find the number of kids wearing hats, H, by setting up a ratio and using algebra. So this is really exactly what we did in the last part of the last exercise, except we've actually reversed the order. In letter A, I'd like you to find the number of kids wearing hats by just using a product. In letter B, I'd like you to do it using algebra. Why don't you pause the video now, do both parts A and B, and then we'll work through both of them. And yes, in both cases, you're going to get the same answer. What I'm trying to illustrate in both exercises is how you can use both a product and algebra to find this answer. Pause the video now. Well, what fraction of students are wearing hats? 7 out of every 20, so 7/20ths. So the easiest way to figure out the number of kids who are wearing hats is to do a product. 7/20ths times the total, 100. Now I can do 100 divided by 20, which is equal to 5. And I can do 7 times 5, which is equal to 35. There must be 35 students who are wearing hats, because 7/20ths of the total are wearing hats. Now, I can also do this with a ratio, right? The way I do it with a ratio is I can say, all right, well, 7 is to 20 as the number of people wearing hats is to 100, right? I could now cross multiply. All right, 20 times h is just 20h. And of course, 7 times 100 is 700. I now divide both sides by 20. And what I would find is that 700 divided by 20 is 35. And I'll skip the long division. Probably many of you would just do it on a calculator, and that's okay as well. Although, honestly, 700 divided by 20 is not too difficult in terms of a long division problem. All right, talking about long division and talking about algebra, let's do a little bit of review of algebra. You see, because what we're going to find next, or what we're going to work on next, is finding the total. So far, both in the last lesson and this lesson, we've always been given the total. And we've tried to come up with the part, either by just using a product involving a fraction, or by using some algebra. But now we also want to try to find the total. And you've done that in previous courses using many different methods. Here we're going to concentrate on using algebra. And in order to use algebra, I'd like to review some simple equation solving techniques. So, exercise number 3. Solve each of the following equations. All right, now let's just take a look at this for a moment. Each one of these equations has the same form, which is there's a number multiplying the variable equal to another number. 5 times x equals 20, 1/4 times y equals 3, 2/3 times c equals 14. All right, now you might be like, oh, why with the fractions? Except almost everything we're doing right now is fractions. So let's talk about each one of these sort of together. Letter A is a piece of cake, right? If I have something like, I'm going to rewrite these problems a little bit bigger, 5x is equal to 20, then to solve for x is as easy as just dividing both sides by 5, right? And 20 divided by 5 is equal to 4. Right, that's no problem. What's a little bit more challenging, obviously, is when you get fractions involved. Now, if I had something like 1/4 times y is equal to 3, I could certainly kind of think about doing this by dividing both sides by 1/4. All right, there's no question I can do that. And since I know how to divide by fractions, I could pull this off, right? It would then be 3 times the reciprocal of 1/4, but the reciprocal of 1/4 is 4. So I'd get 3 times 4, and the answer would be 12. That all being said, the easiest way to actually solve an equation like this, oh man, all sorts of fun with the board. The easiest way to solve an equation like this, when we have a fraction multiplying a variable equal to some other number, and the other number could be a fraction or it could just be a whole number like what we have here, is to actually, instead of divide, multiply both sides by the reciprocal of the fraction. The reason for that is that literally, if we think back to our cross canceling, right? When you multiply both fractions, you look at their numerators and denominators and you think about things canceling. If we multiply by the reciprocal, then all these things cancel and we're just left with a y. Here, of course, we just have 3 times 4. We don't have to worry about the over 1 business, and we get 12. It is particularly helpful in a situation like this, right? So if we have 2/3 times c is equal to 14, then it's really nice to be able to just simply multiply both sides by 3/2. 3 cancels 3, 2 cancels 2. And now this is easy enough. We can cancel a 2 into a 14, gives me 7. 7 times 3 then gives me 21. All right. And we're going to have to do a fair amount of this in the coming exercises, so I wanted to review it with you right off the bat. All right, let's see how we can use algebra and some tape diagrams to think about finding the whole in a situation where we may know the fraction and the part. Here we go. Exercise number 4. In a bag full of candy, for every 8 pieces, 5 of them are gum. There are 20 pieces of gum. We want to find the total number of pieces of candy. All right, so let's talk about the information they give me up front, right? For every 8 pieces of candy, 5 of them are gum. So right away you should know that means that 5/8 of the candy is gum. 5/8 of the candy is gum. Then, where we would normally be told the total number, in this case we're told the part, right? There are 20 pieces of gum. We want to find the total number of pieces of candy. And we're going to call that C in this problem. So let's take a look at letter A. Fill in the missing pieces of the tape diagram below to determine the value of C. Show the calculations you used. All right, this is really cool. It's almost the inverse or the opposite of what we were doing before. We have 8 sections. The reason we have 8 sections is that 5 out of 8 are gum, right? So of those 8 sections, I'm designating these 5 as holding the 20 pieces of gum. Well, then how many are in each one? Well, I could say I've got 20 divided by 5, and that gives me 4. So there should be 4 pieces in each one of these boxes, right? They're all even-sized boxes. They all should hold the same amount, right? And I know then there should be 4 in each one of these, which means there should be 4 in these as well. So how many total pieces of candy do I have? Well, now I can say I've got 8 of these boxes in total. I'm going to multiply by 4, and I'm going to get 32. That's going to be my total amount. So it's really cool. You know, in previous problems that we worked with tape diagrams, right, we would have the total and we would take these boxes and we would divide, the total by the number of boxes to figure out how many are in each box. And then I'd, multiply by the number in each box by how many boxes were, the part represented. Here I'm literally going in the reverse, where I know how big the part is. I know how many boxes represent the the part, so I can figure out how many go in each box, and then I can multiply by the number of boxes in the total. 20 divided by 5 gives me the 4, 8 times 4 gives me the 32. Now, let's take a look at how this might work out algebraically. In letter B, it says, find the value of C by setting up and solving a proportion. All right, this is kind of cool, right? Because the proportion makes it quite simple to see. We know that we have 5 pieces of gum for every 8 total, right? Now we're looking for the total, which is C, and we knew that there were 20 pieces of gum, right? The way that we always set up these proportions, right? If there's 5 gum in the numerator here, then the gum has to be in the numerator here. The more I say the word gum, the stranger it sounds to me. But then if the total is down in the denominator, the total should be in the denominator here. Now we can simply cross multiply, okay? So we get 5 times C, which is 5C. And we can get 8 times 20, which is 160. We can now solve this by dividing both sides by 5. And 5 will go into 160. Maybe I do that on the side of my paper if I can't quickly do it in my head, which I can't. And it looks like 32. And what do you know? That is exactly what we got up here, right? And I just used a proportion to solve for it. If you like the proportions, use proportions to solve in this case. Letter C, though, we're going to look at a little algebra. Let's read that one over. Find the value of C by setting up and solving an equation based on 5/8 of the total being gum. Now this is a little tricky, but, right, if we knew the total, right, which we do, it's 32, but let's pretend we don't. If we knew the total, we could figure out how many pieces of gum we had by taking 5/8, multiplying it by the total, and that would give us the number of pieces of gum. Since we don't know the total in this case, we still set it up the same way, which is that 5/8 times the total must be equal to the number of pieces of gum, which is 20. Now again, before we solve this, let's really kind of look at this, right? This is just stating the fact that we've been working with for the last 2 lessons. If I take the fraction of the total and I multiply it by the total, which is what I'm looking for in this case, that's going to be equal to the part. Now I can solve it the way I solved equations in the last exercise. I can actually multiply both sides by 8/5. Now, all of that's going to cancel, and then on this side I can literally say, well, 5 goes into 20 4 times, and then 4 times 8 equals 32. And boy, doesn't this one mirror the tape diagram approach? And here's what I mean by mirroring it. Think about this. In this particular approach, we took that part, which was 20, we divided it by 5, we got 4. We then took the 4 and we multiplied it by 8 to get the total of 32. And that is exactly what we ended up doing down here, right? We took the part, we divided it by 5 to get 4, right? And so those 4's up here. Then we multiplied 4 times 8 for the total number of boxes to get our total of 32. All right? In most upper level math, you're going to figure out the answer to this problem either by doing letter B or by doing letter C. We're going to use both approaches as we move on and as we work with percent problems. For now, let's do one more problem in this exercise, in this lesson. Exercise number 5. At an animal shelter, 3/4 of the animals are cats. There are 48 cats. How many total animals are there? Show how you found your answer. All right, what I'd like you to do now is pause the video and see if you can figure out the total number of animals there are. Now, what a number of people might do if they're reading this problem too quickly is they might take the 48 and multiply it by 3/4. The problem with multiplying 48 by 3/4 is that you'd get 36. And that answer, upon thinking about it at all, should seem nonsensical. In other words, it shouldn't make any sense, right? Because there can't be a total number of animals that would be less than the number of cats, right? If I figured out that the total number of animals was 36 and there are 48 cats, then, like what's the extra 12? right? It just wouldn't make any sense. Now, let me do this using algebra, okay? And here's how I'm going to use algebra. I'm going to let t be equal to the total number of animals. So I'm going to go with the approach that we used in the last part of the last problem. So I'm going to let t equal the total number of animals. What do I know? If I multiply the total by 3/4, I should get the number of cats I have. In other words, 3/4 times t should be equal to 48, right? 3/4 times the total number of animals is equal to the number of cats. I can now solve this equation pretty easily by multiplying both sides by the reciprocal of that fraction. Come on, there we go. Right? These all just cancel away. Now I can do 48 divided by 3. That gives me 16. And now I can do 16 times 4, which gives me 64 total animals. All right. You could certainly also do it with a ratio, right? Or a tape diagram. You could say 3 cats are to 4 total, and then you could say 48 cats are to t total. And you could do your cross multiplying and work it all out. If you did it that way and you got 64, awesome, because obviously you then did it correctly. All right, let's summarize. In this lesson, we didn't look at too much that was new, right? What we were really getting at is, again, this idea of the ratio of a part to a total, right? Looking at that ratio as a fraction in simplest form, then how to use that fraction to find a part if you know a total. We then reversed that idea, both by using algebra and by using proportions and tape diagrams in order to have a fraction, have a part, and figure out the whole from it. That's a little bit more complicated. It's kind of almost going backwards in the process. But we're going to have to do that quite a bit as we move into the percent work. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.